Hello, Legacy Sabers. So today we're going to look at the second day on ellipses. What these are the ellipse but shifted. So basically these are the ellipses that have not a center of 0, 0, they have a different center. Let's remind ourselves how to graph an ellipse though. So very first thing, we first figured out which major axis was it. In this case, it would be a vertical one because the number underneath the y is larger. With that, I know my vertices are located at 0, 4 and 0, -4 due to they are 4 away from one another from the center because of my a value being 4. My co-vertices would be located at -3 and 3 because my b squared value is 9. Oops. Then my foci, remember we had to use that formula a squared minus b squared equals c squared. So my a is 16, b squared is 9, c squared. 16 minus 9 is 7. So that tells me the square root of 7 is equal to c, which is between -2 and -3. So that would tell me that, oh, hold on. Yep, right here. Between -2 and -3. Right here. And right there. So that right there is my ellipse. So now, what happens if we move an ellipse? So remember, it was x squared over a squared plus y squared over b squared equals 1. Now, if I move the center of my ellipse to a point hk, it looks kind of like a circle did when we moved him. X minus h squared plus y minus k squared equals the radius squared. Well, in this case, it's just a little different just because of our a squared over and our b squared, but it is very similar to when our circle moves. So we're first going to always try to find our center first at HK. Now it is going to be opposite of what you think it should be. So if I have a +3 for our H, my X value will be a -3. Okay, let's take a look at a couple of examples here. So I have the ellipse located at x plus 2 squared divided by 16 plus y minus 2 squared divided by 36 equals 1. So, very first thing, 36 is under the y. He is the bigger number. That tells me I have a vertical major axis. This is going to be an up and down ellipse. My center is located at this and this. So x is at -2 because that's opposite of that. And 2 for the y. So I'm going to make that note, -2, 2. I'm going to put a big C by him so I don't lose him. Okay, my vertices. Now, same thing applies again. We need to find our a, which is the bigger number square rooted. So my a is at 6. So that tells me from the center I have to go 6 up and down because it's vertical. So 6 up would be at 8. 6 down would be at -4. Like that. So my vertices are located at -2, 8 and -2, -4. My co-vertices, my b value is 4 because that's the square root of this number. So from my center, I have to go 4 both ways. So that would be at -6 and at 2. So I have one located at -6, 2, and the other one located at 2, 2. Now I have drawn in basically my ellipse right there. Not a very good one, but nevertheless. My foci, still the same equation that I was using last time. So that was a squared minus b squared equals c squared. So 36 minus 16 equals c squared, because a is 6, b was 4. So that tells me 20 equals c squared. So if I square root both sides, That would be 2 square root of 5 equals c, which is approximately 2 square root of 5, or the square root of 20, is 4.47 roughly. So that tells me from my center I have to go 4.5 roughly away. So that would be 1, 2, 3, 4.5. So right here between the 6 and the 7 would be my dot. And my other dot would be 1, 2, 3, 4, and then about a halfway. So about right there. Now you're probably saying, how on earth, Marsh, are we going to actually write those ordered pairs? Well, here's the thing. We're going to kind of cheat, if you want to consider it cheating. Well, I know that my x value is -2, right? Silly pen. -2. And then I went up 2 square root of 5, right? And then I went down 2 square root of 5 from the value of 2. So I could say I have 2 plus or minus 2 square root of 5 for my y. So I went from 2, I went up square root of 20, aka 2 square root of 5, aka 4.5, and then I also went down 2.5 from both sides. So my foci, their ordered pairs are -2, comma, 2 plus or minus 2 square root of 5. Kind of hard, kind of different, but not too bad once you rationalize it through in your head. Let's try another one here. So I have x squared divided by 25 plus y minus 2 squared over 4 equals 1. So x has the larger denominator, so this tells me I have a horizontal major axis. My center, notice how x does not have anything with him, so he is going to be 0, but my y is going to be 2. So I have a center at 0, 2 right here. I'm going to put a little c by him. There we go. My vertices are located at, well, my a is the larger number, and that is a squared, so my a is 5. So that tells me my vertices have to be 5 away from my center, and in the horizontal direction. So I'm going to go 5 this way, put a dot, 5 this way, put a dot. So it tells me my vertices are located at -5, 2, and 5, 2. My co-vertices, I need my b value, which this is b squared, so b has to be just 2. So that tells me I go 2 in both directions, up and down, so 2 and 2. So I have a co-vertice of 0, 4 and 0, 0. So let's go ahead and draw in our ellipse here. So I got my drawing right here. There we go. So now we got to find our foci. So we're going to use our equation, a squared minus b squared equals c squared. My a, remember guys, was 5. So I got 5 squared minus my b, which is 2 squared equals c squared. So 25 minus 4 has to equal c squared, or 21 equals c squared. So if I square root both sides, I need to know what the square root of 21 is. About 4.6 roughly. So that tells me in the left and right direction I have to go 4.6. So really, really, really close to our vertices this time. Like super, super close. There we go. So my two foci are located there and right there. Now, got to kind of cheat again to write our foci's coordinate points. So we're going to use our center. Now notice guys, I went left and right, so it's going to affect our x value because they're still located at 2 for our y. And I went 4.6 left and 4.6 right, which was the square root of 21. So I would say I went plus or minus 21, 2. Those would be the two ordered pairs of those two dots. Now, what if we want to find the equation of the ellipse? that's been moved. So I have an equation that's vertices are at negative 2, 1 and negative 2, 9. My co-vertices are at negative 4, 5 and 0, 5. Let's draw a picture, shall we? So I have vertices at negative 2, 1. That would be like right here. Other one, negative 2, 9. That would be like right here. So it looks like I do have a major axis up and down. My co-vertices are at negative 4, 5 and 0, 5. So right there. Now, you're probably saying, how are we going to find the center? Well, think of it this way. My center has to be in the middle of the vertices and the co-vertices. So basically, I need to find where the midpoint is between those. So if I find my midpoint between my vertices, I would be going negative 2 plus negative 2 divided by 2 and 1 plus 9 divided by 2. That would be at negative 2 comma 5. So this is where my center is located. So I can start to write my equation. That would be x plus 2 squared over something. I'm not sure on the something yet. Y minus 5 squared over something equals 1. Now, let's find our A and let's find our B. So A, guys, remember back, A is the distance from the center to our vertices. So how much difference is there? So if this is negative 2, 5, and my vertices are located at negative 2, comma 1, it looks like there's a distance of 4 here, right? And then a distance of 4 here as well. So that would tell me my A squared, which is located under my Y, because that's my major axis, is Y this time. I would have 16 under there. Now let's find our co-vertices, our B value. Well, distance from center to co-vertices was B, so that would be a distance of 2. That's a distance of 2 right there. So this would be 4 located under my X. Let's try another one. So I have the equation of my ellipse with vertices at negative 3, 4 and 5, 4, foci located at negative 1, 4 and 3, 4. So we're going to have to draw a picture because that's the easiest way to draw and to figure these out. So I have vertices at negative 3, 4, so that would be like right here, and 5, 4, like right there. Foci located in the same area, negative 1, 4 and 3, 4. So my ellipse looks something like this guy, right? Which tells me I have a horizontal axis, major axis, so I know that my X is going to have the bigger denominator. That was kind of icky when I wrote that. Let's fix that. There we go. So I know it's going to be X something squared over something plus Y something squared over something equals 1. And I know the bigger number has to be underneath here. Let's find our center. So the center has to be in the middle of the two vertices, which would tell me I'm going to find the midpoint. Negative 3 plus 5 over 2 and 4 minus plus 4 over 2. 1 comma 4. 1 comma 4 would be my center of my 2. And ultimately, if I had a graph, I could just count in to find it. So that would be x minus 1 squared and y minus 4 squared. I now need to find my denominator. So remember, guys, my A value, which is my vertice to center, so vertice to center right here is my 1, 4. Actually, not there. Right there. I have a distance of 4 this way, right? So, and since I have a major axis, it's got to be under X, because that's a horizontal major axis, so it's got to be 16 here, so A is 4. I don't know B though, because right, we don't know anything about our co-vertices at all. Let's use our equation. So A squared minus B squared equals C squared. A is 4, don't know B, but we know C. What is C? C was the center to the foci. So this is 1, 4, and this is 3, 4. So that tells me there's a distance of 2 from the center to the focus on either side. So c squared would have to be 4 as well. So I got 16 minus b squared equals 4, which tells me b squared equals 12. So if I square root both sides, I get b equals 2 square root of 3, which is kind of close to 4, but just short. Well, b squared has to go underneath here, which would be 12. And that is the equation of my ellipse that locates those information. And that's the end of this video.